Now, in the example number 12, a body is dropped from a height h above the ground. So, it is like the condition is given like that. Is a height is given somewhere h and body is dropped. Body is dropped. Let's change the color. Why don't we change the color? Green color. Body is dropped from h. Therefore, it is having in the downward direction negative velocity at initial position. Initial is zero, but it is going downward, so it is negative, and as well as acceleration is also negative. Fine. Take the dropping point to be origin, so we will be considering this as the origin point. Origin point 0 comma 0. Wow. And upper direction is positive. This is positive, and downward is negative. It is by default, we know it. So here first let's draw first graph. Position time graph, no, acceleration time graph we should start. What is acceleration? Acceleration is because of gravity only, and that is negative. It is g minus g at below this. Then velocity versus time graph. In the velocity versus time graph, what should be our requirement? What should be our requirement? Velocity versus time. Let's erase this. Let's erase this so you understand better, man. So initial position is u is equal to 0. Then a is negative, a is given negative, x is equal to 0. Fine. So acceleration is negative and v is linearly decreasing. So it is starting from here. Velocity is starting from here. It is linearly decreasing. So line should be like that, linearly decreasing from the 0 point. From the 0 point, velocity, initial velocity was 0, and it is linearly decreasing. How? Then what next? Then ST graph, acceleration is negative, so shape should be convex. Shape should be convex. Then next is, see, initially starting from 0, but it just directly converting into 90, a negative value, and therefore it should be greater than 90. So we should have negative slope. And how can we generate negative slope of this convex shape? So this side we already solved many a time. This side theta is greater than 90 degree, so it gives negative. Let's do. Wow, wow, it is done. So it is position is to be taken. Position is to be taken from this position, and it should go like that. Wow, this is the solution. So you can see, you can compare with this. The first is minus g, then you can compare. See, this one is not required as of now. We just need shape, and this is it. This is it. Let's go to example number 13. A body is projected vertically upward from a tower. Wow, 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 from a tower. One tower is going. Let's make a tower here. A body is, let's have another color of body, is projected vertically upward. That means it is moving upward direction. Upward is positive, right? And the tower height is given. Tower height is given h. Tower height is given h. With initial velocity is u is positive. Take the projection of body to be origin. Take the projection of body to be origin and upward direction. Wow. So here, initially u is equal to positive. Acceleration is negative as g is pulling it down in downward direction. So I always, for any body which is moving freely, acceleration is always negative. X0 is h. Fine. Great, great, great. So first graph, let us have first graph. First graph for what? Always go with acceleration versus time. It is much easier for us to do. Negative acceleration, negative acceleration. Let's change the color. It is negative acceleration is equal to minus g. Fine. Then the second one, it should be velocity versus time. Velocity versus time. So initial velocity is given positive. Initial velocity is given positive. So it is u. it is u. See, body is projected vertically upward from a tower height h with initial velocity u, with initial velocity u. So it is initial velocity u is positive, initial velocity u is positive, initial velocity u is positive, and g is negative, means acceleration is negative, acceleration is negative, right? Acceleration is negative. So what it should go, it should decrease, this should decrease, this should decrease. Velocity is decreasing with time, velocity is decreasing with time. So at somewhere 0 it becomes 0, and then in the opposite direction it increases, in the opposite direction it increases. Oh, then what next, then what next? See, acceleration is negative, therefore shape is convex, and we need to check initial u is positive. So theta should be positive, theta should be positive, theta should be positive. Let's change the color. Theta should be positive, so this slope should be positive. This is the slope, this is the slope. So if we draw this graph, it goes like that, goes like that. Let's see, let's compare our graph with this. So here it is minus g, starting with positive, it is declining as it is. This is the constant. This line is inclined line, and if it is inclined line, this will be either convex or concave. If acceleration is negative, the shape is concave, and if it is positive acceleration, this shape will be convex. And then this angle less than 90 if velocity is positive. And if you see on the opposite side, in the opposite side, here velocity is negative. Velocity is negative. Theta is greater than 90, negative velocity. See here, this is the region. Talking about this is the region where velocity is negative. When this u is 0, the particle travels maximum height. You can also understanding of this also. Let's have example number 14. I think you should pause now this video and you should solve this. That's all. A particle start from x is equal to x0. It start from x is equal to x0. Initial speed is given u 10 meter per second and moves with constant speed. Moves with constant speed 10 meter per second. So we can give this as u1, then u2 or v2 is equal to 10 meter per second for 20 second, 20 second, and then retarding uniformly come back to rest and say, okay, let's do it, let's do it. So first is given initial position u is given, here it is given 10 meter per second, right? At initially x is equal to 0. Initial speed is given directly, it is starting from 10 meter per second object. It is having constant speed, it is having constant speed, so acceleration is 0. Let's do acceleration versus time graph and as velocity versus time graph. So for the part 1, let us just divide this into part 1. So part 1, acceleration is 0, v is 10 meter per second for 20 seconds, for 20 seconds. So this is part 1 where acceleration is 0, it is velocity is 10 meter per second and it is for 20 seconds. Part 2, see what is mentioned, this is part 2. Then retarding uniformly come to rest in the next 10 seconds. Then come to retarding uniformly come to next 10 seconds. So after 10 seconds, right, initial velocity v was 10 meter per second for the part 2, and it goes, means final it is 0, it goes to 0, and it happen in time 10 seconds. So if you wanted to have acceleration, So we know that final velocity minus initial velocity, final minus initiality, v minus u divided by time, that gives 0 minus 10 divided by time is given 10, so become minus 1 meter per second square, minus 1. And for the retardation, we know that retardation, if it is retardation, so it is negative acceleration, and therefore velocity decreases linearly. Therefore, velocity decreases linearly. We know that negative acceleration, positive velocity, that means velocity reduces. We know this rule by heart now. So here, then last is ST graph. Acceleration is negative for the last portion. Therefore, it is a convex shape. Shape is like that, like that, like that. And velocity, it was positive. Positive velocity, shape should be positive. Shape should be positive. So what should be shape? Shape should be from this side only. This is positive, less than 90 degrees. So let's go. For the part 1, V is 10 meter per second. Acceleration minus 1 meter per second. That already we know it. Let's do first. So for acceleration, see, for the initial time, acceleration was 0 up to 20 seconds. For this region, acceleration is 0. Therefore, it is the line is flat in this. Then for the second region, retarding uniformly comes to rest. That means for the next region, we already have minus 1 meter per second retardation. For the next 10 seconds, so therefore it is minus 10. Therefore it is minus 10. Now here acceleration is 0. That means velocity is constant. Acceleration is 0, velocity is constant. Here acceleration is equal to minus 1. Velocity decreases linearly. So here acceleration is constant, that means velocity is also constant. Velocity is also constant. Then here acceleration negative, so velocity from positive velocity it decreases to 0. Decreases to 0. Then the last graph here velocity is constant. Velocity is constant. That means for this region displacement is linear. Displacement is linear, and here velocity is velocity is decreasing. Velocity is decreasing here in this case. Velocity is decreasing. Velocity is decreasing. So we need to identify. We need to identify angles. We need to identify angles. Right. So first is that negative. So the shape is like that, convex, convex, and velocity is positive. Velocity is positive. So here we need to just have angle theta will be less than 90 degree. So therefore, first region it is straight line up to 20 it is straight line, and then it is having convex with theta positive. Theta positive is less than 90-degree angle. Simple. Example number 15. Conversion of velocity versus time graph to speed versus time graph. Wow. So as we know that magnitude of velocity represents speed, therefore whenever velocity goes negative, take it mirror image about the time axis. So what is we are converting? If there is a velocity graph, so velocity is having negative and positive both the values. But speed is not having negative value. It is having only positive and positive value. See what is velocity? What is velocity? Velocity is equal to displacement divided by time, means shortest distance, and it is direction. But when we talk about speed, is a total distance. divided by total time. So there is only this difference. There is a difference, and whenever there is a graph like that, see for example, velocity is given like that, but speed cannot be negative. Speed cannot negative. So you just flip this direction. Just flip the direction like mirror image. So it gives a speed graph. It gives a speed graph. Similar here, this velocity cannot be negative when we talk about speed. So you just need to flip this graph. You just need to flip this. So it will be okay with that only. It's okay with this. Let's go further. Now let's read this XT graph. This kind of graph was previously also we have seen this. One graph is representing A line and another is representing B line. So there are different comparison. First comparison, see, body A starts from origin. Of course, body starts from origin and at t is equal to 0, right? It starts from body A starts from origin and body B starts from T1. This is first observation. Second observation, if it measure angle, see both are having theta are having less than 90 degree. This is also less than 90 degree. That means both the velocities are positive. Both the velocities are positive. Then both the velocities are constant. See, there is this graph is constant, this graph is also constant. That means acceleration is zero. That means acceleration should be zero. Or it can have constant also. You can have constant acceleration also. That will work. Then what next? Next is angle of B. If we just compare angle of A compare with angle of B, which angle is bigger? Which angle is bigger? Theta B is bigger. Theta B is bigger. Theta is smaller. That means if angle is bigger, velocity is higher. That means line B shows higher velocity. Line B shows higher velocity compared to line A. Then next comparison is that at this T2, at T2, both are having similar displacement. Both are having similar displacement x1, x1. And last observation, or you can have more observation also. See, B starts from 0. So B travels from 0 to x3 and A travels 0 to x2. That means B travels more. So these are the observation. Let's have one more reading from that. It is given like that. A is here, B is here. It is given. So very similar to the previous case. What you A starts from origin and B starts from x0. A starts from origin, B starts from x0. That is the first observation. Then what is next? See this theta less than 90 degree. Again, the theta for A is also less than 90 degree. So both are positive. Both velocities are positive. Then third, acceleration can have constant value also. That is also okay. Theta, this is theta A, this is theta B. Which one is bigger? A is bigger. See, you can even compare also slope. Directly slope you may compare. The slope is a bigger slope, larger velocity. So theta is bigger, velocity of A is bigger. Velocity of A is bigger compared to B. Then next comparison is given at T0 both are at the same distance x1 and A travels more compared to B. A travels larger compared to B. So we have one more graph. Let's read this graph. Here A graph, it is given inclined line, linear line, and B is having some kind of non-linear curvature. So how to read this? So first A and B both are starting from where? Both are starting from its initial position origin, that is very well known. Then see, we may compare angle of both. This is VA. For VA, we may compare this VA. So theta A, can we say it is less than 90 degree? Yes, of course, we can. And what about for B? We can take tangent is already there. Theta B, it is also less than 90 degree. So both are having positive velocity. Both are having positive velocity. Then see, velocity of A body. This is velocity of A body is linear. That means acceleration. That means acceleration of body A is constant. Acceleration of body A is constant. Then for VB, it is shape is having concave. We know that this is the shape concave. Therefore, acceleration should be positive. For body B, acceleration is positive. So V is positive, acceleration is positive. So V increases. V increases. Then at t is equal to t1. So here this is the point at t is equal to t1. If we take tangent, tt, so this tangent line is parallel to line A. Both are observing equal theta. That means at T1 position, A and B are having same velocity. Both are having equal velocity. Good. Then next, at T0, both are having same distance x1. So it is not here. We can say T0 fine. So not this position, at this position T2. So it should be at T2. At T2, both are having similar distance travel. We may write its name also. This is the T2. Let's call this X1. And B travels more. Yes, of course, B is traveling more compared to A. And then this the tricky part is there. For T is less than T1. So up to this position, let's go up to this position. So this is the theta B, and this is theta A. So can I call theta A is greater than theta B? Theta A is greater than theta B. Theta A is greater than theta B. That means velocity of A is higher. Up to this portion, velocity of A is higher. Velocity of A is higher. Here it should be A. And thereafter, if you just compare this angle, so this is make it tangent. This becomes theta B, and this is theta A. So we know that theta B is greater than theta A. So after T1, velocity of B is higher. Velocity of B is greater, right? So T is equal to T2, B overtakes A in terms of displacement. So let's have example number 16. What is mentioned? The position time graph for two children A and B returning from their school O, this is the point O, to their homes P and Q respectively are shown in the figure. Choose the correct and raise in the bracket below. And this is from the NCRT. See, do not forget to read each and every word of NCRT books. After all, your question paper is coming from the NCRT. May not be directly questions, may not be there, but all the logics, all the fundamentals are coming from the book. So do not forget to read your book. So let's start. So first it is given A oblique B lives closer to school than B oblique A. See this distance travel. So we can see here A is traveling P distance, B is traveling Q, and Q is higher. So who is living closer? Who is living closer? A lives closer than B. A lives closer than B. Second is A oblique B starts from the school earlier than B oblique A. So who is starting earlier? A starts early. A starts early. A starts early. A starts early. Then B. You can see here who starts. A starts early at zero position. B starts somewhat little late after some time. A oblique B walks faster than B oblique A. See, the slope defines that theta B is greater than theta A. This is theta A. So that means what? B. B walks faster than A. Then A and B reaches home at the same or different time. See, when they reaches, see, if you just compare the time, B reaches, B reaches at this position. Let's change green color. So B reaches earlier compared to A. So no different time. There should be different time. A B overtakes. If they're in overtaking, yes. See B. It is crossing. B is crossing. B is crossing. B overtakes A. How many times? Only once. Only once. It is once. So yeah, we can compare. A leaves closer. A starts early. Right. Theta B is so B walks faster. Right. Both are at different time and overtakes. B overtakes A on road once. So this is very simple. Do not forget to solve NCRT book. Believe me, it is very important for the JEE and NEET. Let's have one more example. Example number 7. A woman starts from her home at 9 a.m. in the morning. She starts. Walks with speed. Walks with speed. So initial speed is given 5 kilometers per hour on a straight road up to her office. So she starts from her home. Let us just do this is her home, sweet home. And she goes to her office. Let's make excellent office. Somewhere here she go. So initially she walks at 5 kilometer per hour speed, and she starts walk at 9:00, and she reaches office right at some time, after some time. So here it is given office distance is given 2.5 kilometer. So we can find time. Velocity is equal to distance divided by time. So from that we can find. Then at 5, she starts from 5:00 p.m. She starts returning journey, and she returns home by an auto rickshaw, and the speed of auto is 25 kilometer per hour. Right. And the from same distance she is traveling, and the distance between this is 2.5 kilometers. Fine, it is good. So a woman walks to office first. So velocity is 5 kilometer per hour is given. So we can find S1 distance is 2.5 kilometer is given and starts at 9 a.m. So what time she will take for that? We know that velocity is equal to S T. We can T is equal to S by V. S is given 2.5 kilometer distance travels, and she travels at velocity V5. So ultimately from house to office she need 30-minute time. That means she reaches at office at 9:30. She reaches office at 9:30. Good. Then she is staying part 2. She stay office from 9:30 to 5, from 9:30 to 5, and she is at distance 2.5 kilometers. And mathematically she is at distance from 5 because home we are taking as a origin. That is the reason. Then part 3 we can say from the office she starts from 5. She take auto, and she start from 5 p.m. Returns home. What is speed? V is 25, taking same distance, but here at that time she just need 0.1 hours. That means 6 seconds. 6 not 6 seconds, 6 minutes. So at 5:06 she will be at home. 5:06 she will be at home. Wow, great. So let's draw it. So here this is the x axis, this is time. So see 9 to 9:30, 9 to 9. She starts from the 0. She walks 2.5 kilometer. Then she stay at office. So 2.5 it should be constant for this up to this region. And then she at 5, at 5, at 5. She pick auto and within 5 and 5:06 minute, 5 hours and 6 minutes, she back to home. So this velocity is linear, and this velocity is linear, and this velocity is constant. Very easy. See, this is also again from the NCRT. Do not forget to solve all the NCRT book. The next example. We have one more example from the NCRT book. A drunk walking in a narrow lane takes 5 steps forward and 3 steps backward. We know it. This we have seen this in the cinemas. Various movies are having this kind of a forward and backward stop of a drunk person. So followed again by 5 steps and forward and 3 steps backward and so on. Each step 1 meter long and requires 1 second. So every step is 1 meter long and requires 1 second. Wow. Plot XT graph of his motion. Oh. Determine graphically and otherwise how long the drunk takes to fall in a pit 30-meter away. So here, that person who is having drunk, let's do it, having some bottle on his hand and moving forward 5 meter, right? And then it returns 3 meter. Then from this position forward 5 meter and continues. Wow, great! And for 1 meter step, he need 1 second. Great. So see, this a drunk walking in narrow lane takes 5 steps forward. So we can say S1 for the first step, 5 kilometer travels, not kilometer meter. Yeah, it is not kilometer. A drunk, I'm not drunk. So in T1 5 seconds. So for 1 meter, 1 meter, 1 meter, it is taking 1 second. So 5 meter, he is taking 5 seconds. So total displacement he travel from this position to next position he travels. This position is 5 meter, and total time is 5 seconds. Okay, then he just return 3 meter. So it should be minus 3. It should be minus 3. It should be minus 3. So T2 is equal to 3. Total displacement 5 minus 3. So 2. So this the total displacement, it is 2. And total time 5 plus 3, 8. Yes, it is 8. Then S3 again he moves here 5 positive. So the previously he was already have 2. 2 plus 5, it is 7. Total time taken 13. Total time taken 13. Then what next? What next? Again he again return 3 meter. So 3 meter minus become 7 minus 3 become 4, and the time taken is 6 minutes. Then what next? What next? What next? Again he moves 5 meter, 5 meter, 5 meter. So plus 5, 9. Total time is 21. Again he return 3. So become 9 minus 3, it's 6. 9 minus 3, 6. Again, going forward, 5, 5, 5, 5. Just add 5 and minus 3, 5 minus 5 plus minus 3, you do this. So once you finish, it is at 13, at step number 9. So it is having 13 distance where he will be in the pit, and he needs time 37 seconds for that. And if you draw a graph x versus t, so you start with a linear velocity from 0 to 5, 0 to 5. Then time, you cannot have negative time for that, but movement is there, so it is free. It is negative direction 3, negative 3. It is moving in negative 3. Then plus 5, minus 3, plus 5, minus 3, plus 5, minus 3, plus 5, and he is in it. Wow, so easy, so easy. From the NCRT book, you will find easy questions, but we know the answer. That's why that looks easy. Otherwise, they are also tricky, somewhat. Example number 19, again from the NCRT book. Figure shows the velocity time graph of a body moving in a straight line. A body which is moving in a straight line, which is shown here. Find a distance traveled by a body 20 seconds and the displacement. See, distance and displacement both are different terms. We know it very well. Of the body in 20 seconds and the average velocity in the time interval t is equal to 0 to t is equal to 20. Wow. So see, distance, if you wanted to find, I just multiply v with this area under this region t. So this region you just require to have, and that gives us distance or displacement. So let's have first distance travel. So in the case of distance, we do not consider negative direction. So here in this case, area of AOB plus area of BCD. It is triangle 1 r BH 1 by 2. This is 10. Height is 6. Again 1 by 2. Height is 6. Similar area it is there. So total it become 60 meter. So for the distance, negative sign is not required to consider, because when we talk about distance, we take total distance. But when there is a question of displacement, we need to have area time graph. Again, we need area, but this area is positive, and the another area, this is negative. So it remains sign with this. So distance travel in 20 seconds. Here 1 by 2 and 6, that is okay, positive. But the second graph, it is having negative velocity. So 1 by 2, and therefore it is 0. Therefore, displacement is 0. Here it is not distance, but it should be displacement. Right? So average velocity is equal to x bar x1 by x2 minus x1. So we need last one, the average velocity in the time t 0 to 20 seconds, 0 to 20 seconds, 0 to 20 seconds. So distance, if you see the distance, what? It is 0. Distance is 0, distance is 0, distance 0 divided by time. Time doesn't matter here. It gives 0 as a solution.